A few days ago I was feeling sick. You know how it is. You just feel some kind of muscle pain, maybe you have a fever, maybe you don't have a fever, and in general you feel like the piece of shit. So it was either my kids brought something from the school or for the kindergarten, or somehow I got the coronavirus. So what's the first thing you usually have to do in such a situation? You should measure your temperature and monitor your temperature so you know if you are, let's say, seriously sick or just have some kind of the minor infection and you can live with it. Unfortunately, I realized that I lost my thermometer and was unable to measure my temperature. So I had an option. I could go out, go to the drugstore, get myself a brand new thermometer, go back, interact with people in the rain because it was even raining outside, and if I do have something, then spread it on different people. So that was not really like the best option ever. Or I could just, well, see what I have in my drawers, find some electronic components, and as a result I built this. Today, let me show you what is it, and to some extent it's probably kinda cool. Do-it-yourself weekend project you can do by yourself with Arduino and some electronic boards, and maybe even with your kids, because who knows, they also one day might find that having those kind of programming and electronic skills can be useful. So let me change the camera angle and let me show you what this thing is. This is my build from necessity, do-it-yourself, Arduino based, because I used Arduino to program this thing, thermometer, based on the ESP32 development board with the OLED display, the Dallas DS18B20 digital thermometer that uses the one-wire protocol. There is also a resistor for powering this thing up, because the signal line has to be pulled up to the voltage supplied for the sensor, and the battery to allow this thing to be operated when, well, let's say you do not have the USB plug anywhere near. How it works. I just glued the battery. I have left a few of those from my tiny whoop phase when I was flying tiny whoops. I'm not doing that anymore. Battery connected to the circuit inside of the ESP32 board. By the way, this is one of the arguments to use the ESP32's development boards, because almost all of them in this form factor have the circuit for managing the LiPo batteries. So you can just connect the battery, it will work from the battery, and when you will plug the USB, it will just charge the battery. Pretty convenient stuff. If I power this thing on by just plugging the thing, it will just start displaying the temperature measured by the temperature sensor over here. And you see I keep it between my fingers and the temperature is growing. How to use the thermometer? You just put this thing into anything you want to measure the temperature. In my case it was my armpit, for like 1 minute, waiting until the temperature stabilizes, and that's basically all. One thing I've built added over here is that after 2 minutes after being operational, the board goes into deep sleep mode. It's not super efficient because it's not really powering down the battery circuit over there, so the current consumption is still pretty high and probably would deplete this small LiPo in like a day or two. But this is a battery, you can plug it the USB and charge it again, and that's basically all. If I want to start measuring again, I just press the button, it resets the board, and the whole procedure starts again. Super simple, nothing fancy. Building of this thing took me like, I don't know, maybe half an hour in total, maybe slightly longer, because I had some problems, because I forgot to write few lines and it was just resetting all the time. So now let me show you the code and how this thing is working from the code, from the Arduino point of view. Let's have a quick walkthrough to the code to see how this thing is working. Basically, super simple stuff. The most important part are those two libraries. Dallas temperature, which allows you to talk to the DS18B20, and the one-wire library that provides the support for the one-wire protocol. There is also Wi-Fi included, but only because I wanted to disable Wi-Fi, and that was just the simplest way to do it. I will show you this part slightly later. And some device, for example, when the OLED display is connected. This specific board needs a reset pin, and the reset pin has to be put to high for the OLED to be working. Definition for the SDA, SCL pins for the OLED display, the address for the OLED display, and the information on which pin the thermometer is connected, in my case pin 13, and from which pin I'm powering this thing up. Then we have the definition that one wire will be protocol, one wire will be used on the DSB on the pin 13 where I connected, and Dallas temperature framework that allows to read temperatures from the sensor, and of course the driver for the OLED display. Then we have a section that initiates the OLED display. It does it by pulling the reset pin on the OLED low and then 50 milliseconds later high, and configuring the I2C. Initializing the driver for the OLED display and flipping this thing vertically because how I wanted this thing to be positioned. And finally the initialization of the sensor itself, where I set the power pin, the pin that powers the DS18B20, pin 12, and then the start of the whole temperature framework, and stopping Bluetooth and stopping the Wi-Fi. Then in the loop, super simple stuff. Every loop I'm just getting the current temperatures and the first temperature from the sensors connected in the daisy chain. I have only one, so of course it's index 0, and displaying the information on the display. Big font, position on the display and the display, and then the code waits 100 milliseconds, because why it should be doing anything useful, right? And finally, because originally I wanted to conserve some of the power and allow this thing to work longer on the battery, I failed over here, because without disabling additional elements on the boards like the voltage stabilization, I was able to go only down to around 7 milliamps of current drain, which is slightly too much, but it's less than the 50-60 milliamps when this thing is working. So even if I do not disconnect the battery immediately, it will not kill the battery in like half an hour. If the current millis for how long the code is running is greater than the deep sleep time, it's the number of milliseconds times the number of seconds in the minutes time 2. So after 2 minutes, ESP goes into the deep sleep mode and also shuts down the power of the sensor. And this is basically it. If I want this thing to measure the temperature again, I either have to cycle power or just reset the device, will start the whole process again. So, is my ESP32 thermometer the best device ever, and that I created something unique and super awesome that I would share with everyone? No, definitely not. It's a super simple device that I just built from what I had in my drawer. I used generic, publicly available knowledge about all the components, and I even found some pieces of code in the internet, because I, for example, never remember how to connect DS18B20 thermometer to Arduino, and I used publicly available and ready for you to reuse them libraries. However, I think it's I like what I did over the hour one day when I was feeling slightly sick. And if I would have to upgrade this thing one day to make it better, probably adding some kind of the web interface, because come on, it's the ESP32, it can have Wi-Fi and you can connect to it with your smartphone. It can act as the web server after all, or maybe improve slightly power handling and lower the power usage, but I had no time for it. As the result, without spending too much, because probably all the components are even cheaper than getting yourself a good thermometer in the drugstore, I create something useful, right? Right. So that's all for today. Until the next one. Bye bye.